Hello dear acoustics fellows! In this video we will explain and present the acoustic beam shape and characteristics. The transducer converts the electrical signal generated by the hardware into an acoustic wave. When vibrating, the active surface of the transducer is comparable to a lot of small elements vibrating, resulting in a diffractive phenomenon and in a spherical wave. The active surface is characterized by its radius. The beam shape can thus be represented by the following model of the Rayleigh integral. A longitudinal model is given by the Fresnel approximation. An example is given here. The last maximum position defines the near field length, which is given by the square of the active surface radius times the emission frequency divided by the sound speed. A transversal model is given by the Fraunhofer approximation. The first zero position defines the aperture half angle, given by 0.61 times the sound speed divided by the radius times the emission frequency. The near field distance and aperture half angle determination allow to define a simplified beam shape model, the cylinder cone model, which contains 90% of the energy. The cylinder cone transition position is given by 1.6 times the near field distance, and the half angle of the cone is given by 0.63 times the aperture half angle. This model allows to determine, for example, the cell diameter and volume at a certain distance. Nevertheless, in the Rayleigh integral representation, we can see that there are side lobes. When measuring in an oblique direction to an interface, such as a flume bottom, those side lobes will reach the bottom before the main energy on the transducer axis. This will result in a biased zone near the bottom when measuring with the monostatic UVP method. Also, near the bottom, and considering the volume of the beam, some cells will partially reach the interface, resulting in sometimes unwanted velocity averaging of the whole cell information. You can have a look at the static echo filter option for this. Thank you for your attention. We hope this helps you in understanding acoustic measurement technologies. If you have any questions, do not hesitate to contact us. The link is in the description. Bye!